Hi, this lecture is on Introduction to Limits. In this lecture also, we will learn on how to find the limits of a function and also what are the basic properties of limits. The definition of a limit. If the function f(x) approaches L when x approaches a, we say that the limit of f(x) when x approaches a is L, and it's written as this. Please do take note that when we are dealing with the concept of limit, we are not interested in the value of f(x) when x is equal to a. We are only interested in the behavior of f(x) as x comes closer and closer to a value of a. For example, we have a function f(x) and a point x equal to a is labeled on the graph. Let's say this red dot is the point x equal to a. We are only interested in the behavior of f(x) as x comes closer and closer to a value of that a. The value of the limit at x equal to a is L. When we look at the value of the limit from the right side of x equal to a, that's why we write positive on top of a, which refers to the right side of a. And then from the left side of a, we write it as a power negative, which refers to the left side of a. And the value of the limit, the y value, is also L. Remember, the value of the limit is the value of y. You get it from the y-axis. And the value that you want to see approaching to is the value of x. Let's look at this example. Find the limit of x squared plus 1 as x approaches to 0. You don't have to answer this in the exams, but I'm just showing you the concept of limit. Alright, so let's say we did not sketch the graph, and I want to show you what happens when it approaches to 0. And let's say I start by the number -1 and +1. So when I substitute in -1 into the x, -1 squared plus 1, you get 2. And then I substitute in -0.5 squared plus 1, and so on. So this is the values of x when it approaches 0 from the left side. So the value of the limit of x approaching 0 from the left side, as you can see here, is 1.00001. But this value is at -0.001. We want it to approach 0 from the left. So the value with it is approaching to is 1. Because when you substitute 0 inside here, 0 squared plus 1 is just 1. And then from the right side of the function, you can substitute the values inside, and you see that from the right side, the value is also approaching to value 1. Okay, so it's very near. When you substitute in 0.001, it's very near to 1. And exactly at 0, the value is 1. So both from the left and right side, both limit is approaching to value 1. Let us visualize by sketching a graph. For example, this is your graph, x squared plus 1. From the left side, the value of y is equal to 1. And from the right side, the value of y is equal to 1 at x equal to 0. So since the value of the limit from both left and right side is approaching to the same value of limit, which is 1, then our answer is 1. Next example. We want limit as x approaches to 3. So when you substitute in 3 inside, 3 squared minus 9 over 3 minus 3, you get it's undefined because what you get is 0 over 0. So what is the value of the limit? Is it also undefined? Well, the value of limit is not undefined because the value of limit just cares about what is the behavior or what is the value as it approaches to 3 from the left side of 3. So we can start by substituting a number which is close to 3. For example, 2.8, 2.9, 2.99, 2.9999. So you can substitute and replace your x here and press your calculator. You will see that the answer is 5.99 and is very near to the value 6. Try to do the same from the right side of 3. You can choose any number which is bigger than 3 but close to 3. For example, 3.01. And you see that the value from both left and right side is very close to value 6. Although fx is not defined at x equal to 3 because it's 0 over 0, the limit depends only on the values from the left and right of fx, where x are close to 3, not at x equal to 3. So since we know that from the left and right side of 3, we see that the value is very close to 6. So the limit is 6. In the next lectures, we will learn an easier method to solve this type of question. Let's look at the properties of limits. There are quite a few. The first one is, if fx is a constant c, then the limit is just that constant. Remember in the tutorials as well, I have explained this. Why is it constant? For the value, the same as the function, because there's no x there. So where can we substitute the value of x? There's no x. That's why the value of the limit is just 5. Just the constant. But if fx is equal to x, then just substitute in the value of a into your x. That's why it's a. For example, like this. Substitute 4 into the x, you get the value 4. And if fx is equal to x power n, where n is positive integer, then x power n is the function when you substitute is just a power n. For example here, substitute replacing 4 inside the x is just 4 power 3. The answer is 64. Let's look at example 2. The first question is to find the limit of 3x squared plus 4 as x approaches to 2. Remember in the tutorials, we always check what is the function from the left side of 2 and also from the right side of 2. But for this question, example 2, there's only one function given. And there's no piecewise function. So we can straight away substitute the value of 2 inside the x's. But to show you the properties of limits, if let's say we have a plus in the middle of the function, we can separate it into 2 limits. And then if we have 3 times a function and 3 is a constant, we can take 3 and bring it to the front of limit. So you can substitute in value of 2 inside the x. 3 times 2 squared plus 4. The answer is 16. Next, example B. Also the same thing. If there's a minus sign in the middle, you can separate it into 2 limits with the same value of x approaching to 4. And then substitute your value of 4 into the x. And find the answer. The answer is just 4. Look at example C. Remember in tutorial 1, when there is an absolute function here, I separate it into a piecewise function. But why is it for this question, I'm not going to separate it? That's because when I substitute the value negative 3 inside the x's, I do not get 0 over 0. So I can still get an answer value of the limit. So there's no need to separate this absolute x to a piecewise function. And from the properties of limits, if this is a function divided, you can also separate the limit to be limit of the numerator and also divide with the limit of the denominator. And then just substitute the value of x. Since negative 3 modulus is equal to positive 3, and on top, the answer is negative 27 divided with positive 3, the answer is negative 9. Same for D. If we have the function as a fraction, then we can separate the limit as the numerator and also the denominator limits. Okay, separate into 2, and then you can substitute the value of x. And it's 18 over 31. You don't necessarily need to separate the limits like this if it's not needed. So from example 2, we have seen this additional property of limits, which is if we have a constant c, we can take it out. For example, 3 times function f, you can bring that constant 3 to the front of lim. Since the value of limit of fx is equal to 3, we can simply substitute this value as 3. This is an example of where we have to use the properties of limits in the question. It's whenever the question gives you an information like this, which is limit of fx as x approaches to 2 equal to 3, and also limit of gx as x approaches to 2 is equal to 8. Only two informations are given, but we need to solve limits of 3fx as x approaches to 2. As you can see for this question, the value or the function fx is not given. So we have to use only the two informations to solve this value of limit. And to do that, you have to apply the properties of limit. So that's where you have to know what to do next. Since 3 is a constant, you can take it out. And this value is just the one given in the question. The next property is when is the limit of a square root of function f is also equal to the square root of all of the limit. Look at an example. Let's say we want to find the limit as x approaches to 2 for the square root of 2 gx, but we only know what is the limit of gx as x approaches to 2. So what we do is we apply the property, extend the square root of all of the limit, and then we have to bring 2 outside or to the front of the limit because the information given is only limit of gx. So we can only substitute in the value of 8 once it's in the same form. That's why it's 8 times 2. So square root of 16 is 4. Next example, the other property is if this is function of fx to the power of n, it's also equal to the limit to the power of n. And for example, we want to find the limit of fx to the power of 5, but we only have this information of fx. Remember to substitute this value, you need to make sure it's exactly in the same form. But now it's not in the same form because you have power 5. So you have to apply this property, put the bracket outside, and 5 means the power for all of this limit. Now we have the same form because the limit of fx is inside the bracket. Before we change it, power 5 is only for fx. Now power 5 is for all of the limit, and we know what's the value for all of that limit. The value is 3, so 3 power 5 is equal to 243. Next property, if limit fx as x approaches to a and limit of gx as x approaches to a exists, then when we have two functions added or subtracted together, we can separate it into two limits. For example, limit s of gx minus 2fx, but the only information that we have is limit of fx and also gx. Make sure you separate them so that they're in the same form. separate this, write a minus in the middle, okay, and then since 2 is a constant, bring it to the front of the limit. Now you can substitute the values that's given in the question, because limit of gx as x approaches to 2 is equal to 8, and then limit of fx as x approaches to 2 is 3. The next property is, when we have two functions multiplied together, then we can separate it into two limits. For example, fx squared times gx. First, we can separate them into two limits. And then, since function of fx is squared, we can put the bracket for all of the limit and then put the power for all of the limit. Substitute your value of limit, which is 3 for f and also 8 for g. Notice that there is a power 2 for the limit of x, so this is just 3 squared times 8. The answer is 72. Now, the next property is, if we have limit of a function f divided with g, we can also separate it into limits of two functions. And the condition for this formula is limit of the denominator cannot equal to 0. Let's look at an example. Find the limit of x approaches to 2 for function 2f divided with gx. Remember, we only have the information about the limit of the function fx and also the limit of the function gx. So we have to separate this into two limits. And then, since there's a constant 2 right next to f, you have to take it out. So limit of fx, you can change it to the value given in the question, which is 3, and also gx is changed to 8. Simplify that, the answer is 3/4. Let's look at example 3. Given that limit of fx as x approaches to 1 is equal to 4, and limit of gx as x approaches to 1 is equal to 1. Evaluate limit of hx as x approaches to 1 if the limit is given. Alright, so list down the information that the question has gave you. And the one that we want to find is the limit of hx. And where is hx? It's right in the middle, here, at the denominator. So to find this, you have to make sure you have written it in the same form. So we have to apply the properties of limit. Start by separating the limits. When we have addition in the middle, we can separate into two limits. Write the same value of x approaching 2. And then when it's divided with hx, we can also write down the limit in front of that h. Next, since there is constant 2 right next to g, you have to take it out, bring it to the front. Alright, and after that, make sure you have written limit of fx as x approaches to 1 exactly the same form as the one given in the question. So substitute that value, and also the same for gx. Only substitute the value of lim of gx with 1 and leave 2 in front. You can also bring limit of hx to the right side so that it is simpler for you to deal with. Substitute the values of limit fx and also limit of gx. And just leave limit of hx on the right side because that's what we want to find. Remember? Okay, and then just divide. 6 divided with 2 is equal to 3. That's your value of limits of hx. Thank you for watching.